Hello everyone, I'm Sri and this is my video report for Lab 1, which is the Charge Tapes Lab, and this is for Physics 2212. So for the introduction, first let's start off with the purpose of this lab, and that is to find the excess charge on one piece of charged clear tape and find how charged pieces of tape interact with other objects. Some physics principles we'll be needing for this lab are Coulomb's law, which basically tells you the electric force, and then how charges interact with each other, meaning like charges repel and opposite charges attract. And we also need to know Newton's second law to find the gravitational force, which we'll do later. And we need to know what equilibrium is, and that's basically when the net force acting on a system is zero. So for the model and assumptions, we have that the system is tape A and tape B, while the surroundings are everything else. And when tape B starts to float, the electric and gravitational forces must be in equilibrium, which basically means that they're equal in magnitude but opposite in direction. And for assumptions, we have that the charges on both tapes are equal, air resistance is negligible, and the tapes are point charges, meaning that all the charge is concentrated at the center of the tape. So for the experiment, when tape A was brought close to tape B started floating, which shows us that both tapes repel each other. And since the negatively charged pen that I obtained by rubbing into my hair was attracted to the tape, we know that the tape is positive because opposites attract. So here's a preview of my results, calculations, and measurements. So for the length of tape B, I measured it to be 0.204 meters, and I found the width to be 0.019 meters, and that corresponded to a mass of 0.00204 kilograms. And I measured the separation distance, which is the distance between tape A and tape B during the experiment, to be 0.024 meters. And I noticed that the charged pieces of tape repelled each other, and we already know that the charged pieces of tape were positively charged. And I found the charge on the tape to be 1.132 times 10 to the negative 8 coulombs, which meant that it was deficient of 7.077 times 10 to the 10 electrons. And this corresponded to a ratio of 1.826 times 10 to the negative 7 electrons per atom. So here are some calculations I did to find the results that were mentioned in the previous slide. So first, to find the charge on the tape, I set Coulomb's law equal to Newton's second law, and I found that charge is equal to the square root of mass times gravitational acceleration times r squared over Coulomb's constant. And I later found that the number of electrons could be found by dividing the charge that I got previously by the fundamental charge to find the number of electrons, and the number of atoms could be found by dividing the tape area by the area of an atom, and I could find the ratio of the number of electrons to number of atoms by dividing the number of electrons by the number of atoms. So this is the code I did, and basically I just computed the same calculations but using code this time. So in the beginning, I just set some variables and I assigned them to the values that they corresponded to. And I did all the formulas for it on the second part of it. And then in the third part of it, I made a model, which I'll be showing you now. And this is the model I made using GlowScript. So the blue ball is tape B, and the yellow arrow is supposed to be the electric force on tape B caused by tape A. And the purple arrow is the gravitational force of tape B. So here are some conclusions I had. So since both tapes repelled each other, we know that the tapes were of equal charge, and we know that both tapes were positively charged. So overall, we know that both tapes were positively charged. And for some sources of error, the tape might have been mishandled by me, and the charge may not have been the same for each tape as we assumed. So for the what if question, what if electrons had positive charge and protons had negative charge? Nothing would change because charges will interact the same way, like charges repel and opposite charges attract. And why is it important to handle the charged tapes as little as possible? That is because we don't want our hands or any neutral objects to affect the charge on the tape, because it could neutralize the charge and affect how it interacts. Thank you for watching my video report for Lab 1.